chemical physicist, nuclear radiation poisoning expert, Dr. Christopher Busby, is our guest. Doctor, you were getting into radiation levels rising in and around the Holy Land, but then I wanted, in the brief time we have left with you, correct me if I'm wrong, but the system is openly just saying, look, we're just going to raise normal background levels and just get you to accept that radiation is good for you, and the Japanese ought to be thankful. And just like until 1991, they wouldn't let the troops use DU. After that, they waved a magic wand, said ignore all the old Army reports saying it'll kill troops, with a soft kill in a few decades if they use this weapon, maybe even quicker. And now they just say go ahead and use it. So the attitude is just go all the way.
Well, radiation is not good for you, and the risk agencies, all of the international risk agencies, will state in their documents that the smallest dose of radiation can cause damage, and that damage can lead to cancer. So radiation is not good for you. So that's the first thing. The second thing is that if you have a set of regulations that relate to something that's acceptable in terms of radiation exposure, in other words, to illness, because they've just said that is illness, then you can't just suddenly change those. I mean, in what way do you have any mandate from the people, from the public whose taxes pay you to protect them, to just arbitrarily change the baseline when you decide that it's useful to the nuclear industry to do that? It's totally unacceptable. It's quite wrong. It's in fact criminally wrong, in my opinion.
Yes, sir. You were, before you got interrupted by the break, you were getting into increased radiation levels in Israel?
Well, I was saying that following the increase in the concentration of uranium from the uranium weapons usage in 1991, the whole of that area has become contaminated with uranium particles. And there was a study done a couple of years ago of sperm counts in young men in Jerusalem, and I think that the figure was that there was a 40% reduction in the last 10 years in the sperm count, the viable sperm count in young men who were studied in this Jerusalem hospital. And the conclusions of the people doing the study said that if it continued at that rate, because there was a rate of falling over the last 10 years, by the year 2020, there would be no more Israeli people. That would be the end of it, because everybody would be infertile. I think that's rather a problem, really, and it's similar to the general fall in sperm counts that have occurred globally since the weapons fallout in the 1960s.
Now, looking at this, obviously this is a disaster for the nuclear industry. That's why they're trying the psychological tactic of just throwing it in everybody's face right now. Do you think that's going to be successful with their psychological judo of saying everyone should be thankful, this is good?
Well, I have to say that we have had massive support for the various programs where I've managed to get into the media to argue all of these things that I've been arguing. Basically, arguing that the dose risk idea that they have, the risk model that they have, is totally incorrect for internal radionuclides, and I think that people are not fooled anymore. I have to say that. I think probably because of the internet and because of people like you, people who can get the truth out onto the internet and through independent channels of communication. I think that the public are no longer fooled. Anyway, I sincerely hope that that's the case. And they are voting with their feet too. They aren't drinking the water and they aren't drinking the milk, and so they're not really taking the advice that is given to them by the authorities.
And now it's all over the Japanese news that the people are becoming enraged. They know they've been lied to. So even the very polite Japanese, slow to anger, are coming out and saying, we know this is a fraud. I've seen the reports now for 2 weeks, though, that Japanese doctors are so concerned about radiation that they're refusing to even treat, in some areas, people with radiation poisoning because they don't want to come in contact with them. I mean, that's terrible on the surface, but that'll give you an idea of just how serious this is.
Yes, it is very serious, and it may even be more serious than is being suggested now. Last time I spoke with you, I said I thought that this was a singularly Japanese problem, but I think that these reactors are still fissioning. We know from the isotope ratios that are being measured. Some of the isotopes that are being measured are very short-life isotopes, which only occur after fission, and so we know that these reactors are still fissioning. So this material is still being released. It's not as if it all released concrete and hope it'll go away. That isn't the case. What you've got is naked reactors functioning there on the ground in the open and producing radioactivity, which is slowly going to pollute the planet. And something has to be done about this. It's potentially extremely serious.
Dr. Busby, do 5 more minutes with us, then we're going to go over everybody's calls. I want you to be able to finish up with the fact that we have these boiling, burning, exploding cauldrons, and now the Japanese government, under the radar, says this could go on for months. This could go on for years. We'll be right back and look at the different scenarios that could unfold. Dr. Christopher Busby, radiation specialist, chemical physicist, is our guest for a few more minutes. Then I'm going to your phone calls and other important news today. But when we went to the break, you were getting into the fact that this is ongoing. And it's so bad, the radiation's so high, they've pulled out the emergency workers yet again. And they're talking about people getting, in just 5 hours working there, enough of a dose that the head of the plant said it would roughly kill half the people that come in contact with it. We're not seeing a lot of reports about radiation sickness. We see some going back 2 weeks ago in the hospitals. So it looks like that's being underplayed there. We see our media here in the United States saying, hey, don't worry, the government's just raising the safe level. But I want you to speak about the different scenarios that can now unfold at these 6 reactors, including 2 of them they successfully shut down. Number 5 has still had problems and partial meltdown. I want to talk about that in closing, but I also want to go back to, you mentioned an event in Russia in the early 50s where a facility holding rods actually blew up, and I want to talk about what type of explosion that was. Please continue.
Yes, okay. Well, as far as the future is concerned, we are really in science fiction territory, so I don't want to make too many predictions about this. What you have is you have reactors that are reacting, that normally would be reacting inside a metal container where everything was kept inside and all the radionuclides were inside it. But these are now reacting outside. And so all the radionuclides that are being produced, all the huge amounts of fission and neutron radionuclides that are being produced are just being distributed out into the atmosphere and into the water that's surrounding this. And then, of course, when the rain falls, goes into the sea, and then the sea will then distribute this stuff up and down the coast, and eventually it will begin to contaminate the Pacific. The Pacific is very big, though. So, I mean, in a few months' time, I don't think that the long-range problem there will be very great. But a lot of the gaseous radionuclides will certainly make their way across to the United States, and already they're doing that, and there are increased levels there, which I think are now becoming a cause for concern. So you've got this stuff out of the box. That's the problem there, and something has to be done about it. Now, I have to tell you that and this is some confidential information that came to me. I can't say who from, but they're so concerned about it, the authorities, that they've developed an argument between the United States advisors and the French advisors over what to do. And the United States advisors wanted to bomb these reactors into the sea, and the French advisors wanted to drop concrete on top of them to sort of seal them up. But the problem there is if you seal them up, they're still fissioning away underneath the concrete, and that will go on virtually forever, certainly for a very long time, as much as a year. And so we have, and there would be a good argument for bombing them into the sea, because rather than taking the seawater to the reactor, you take the reactor to the seawater, and then if you split it up into small enough pieces, you reduce the fissioning. Then, in a sense, you could seal off that bit of sea and then pick them up with robots from under the water. That might be a possibility. But like I say, this is science fiction stuff, I mean, who can possibly figure out what the best way to do this is? We have a global catastrophe on our hands here. As I said, it was potentially a global catastrophe. Now we go to Kishtim. In 1959, I think it was, there was 57. There was an explosion in Kishtim in the Mayak facility at Chelyabinsk, and that was an explosion related to fuel rods, which melted down in a nuclear waste repository, and the explosion contaminated, I think it was 1,000 square kilometers of land, which became completely isolated. Nobody could go in there. It was highly radioactive. So it is entirely possible that there might be an explosion, but I think actually in the case of this, unless the plutonium concentrations get high or become separated in some way, then probably there won't be an explosion. There'll be like a sort of ongoing explosion, if you like to think of it like that.
Well, that was my next point, is that I've read some physicists say that if they are able to separate out the plutonium, the uranium, and then other isotopes, that you can get some type of actual chain reaction. Then I've had other physicists on who say that they don't think that that was possible, but the same physicist said he didn't think 5 or 6 could have a meltdown because they'd been shut down before the event, and 5 has now.
I don't think anybody knows quite what happens at these temperatures under these conditions, and there are all sorts of parameters that have never been involved before, like seawater, like sodium chlorides, like molten salts, all sorts of things that would never have been experimented on. So in principle, it might be possible for, if the plutonium to separate from the general mix, for there to be a Kishtim type explosion, in which case it would blow all this stuff, vaporize all this stuff up into the atmosphere, and then we would really be in deep trouble. So there might be some argument, and I think maybe this is why there was this panicky, hysterical decision to bomb them into the sea. But maybe there's some sense in that. Who knows?
Okay, final question, and we're going to let you go, Dr. Busby. We appreciate the time. Looking at this situation at Fukushima, I know you don't like to look into the future, but they've said it could go on for months or longer. I mean, from researching this, from seeing other cases, how long do you think it could go on, A? And then B, we see reports of governments and the UN saying that Chernobyl in '86 was 400 times a Hiroshima. Why are reactor meltdowns so much more dirty than an atomic or hydrogen explosion, or is that wrong?
Yeah, no, that's right. They are more dirty, and the reason they're more dirty is because they have vast amounts of uranium. I mean, the atomic bomb at Hiroshima was a limited amount of uranium. I don't know, kilograms, maybe a ton total. What we're talking about here is several thousand tons. I mean, the fuel rod, the number of spent fuel rods there, as I understood, it was about 1,700 tons of spent fuel, and each of these reactors probably contains about 100 to 150 tons of uranium and plutonium and mixed radionuclides. So there's just a lot more stuff. That's basically it. The Chernobyl accident, which I think actually now, having talked to some Russians last week in Berlin, was a nuclear explosion and not a hydrogen explosion, because there was a particular fission ratio of xenon isotopes which defined it as a nuclear explosion. That one vaporized at very most 200 tons, and the argument was that it was only 50 tons. Well, here we have a lot more than that. We have a huge amount of fuel here that can go up in the air, and a lot of it already has.
So clearly, from the Russian example, some type of chain reaction is theoretically possible. Again,
No, that is right. The Russian explosion, which everybody has said, and they still are saying, was a hydrogen explosion. I talked to some Russian nuclear physicists last week in Berlin, and they showed information from the Radium Institute in St. Petersburg. They measured the isotopes xenon-133 and xenon-133m, and the ratio between those two isotopes defines whether it's a nuclear explosion or whether it's just a nuclear fission inside a reactor. It's either 22 or it's 12, and I think it was 15. So in other words, it was mainly a nuclear explosion, Chernobyl, not a hydrogen explosion, as they said. And my belief is that these also have been nuclear explosions and not hydrogen explosions.
Whoa, I said last question, but this is bombshell. You're out there, you're on major boards in Europe, you're talking to top nuclear engineers, and not only does it look like there was a nuclear explosion at this 50s event in Russia, they're saying Chernobyl was really some type of atomic chain reaction.
Correct, absolutely so. The definition is based on the measurements of xenon isotope ratios made at the Radium Institute in St. Petersburg. It was given as a paper by 2 Russian nuclear physicists from that institute last week in a Chernobyl conference in Berlin, where I was talking.
Dr. Busby, can I ask you a favor, or a favor for humanity? I want to have Kurt Nimmo, one of my writers, right now. We'll call him up here and call you back at home or your office, or can you send to an email we'll give you maybe a 2-paragraph write-up to make sure we get the isotopes correct?
Yeah, sure. They are xenon-133 and xenon-133m, which is a metastable isotope of xenon.
Sure. It's just my writers, because they're not nuclear physicists or chemical physicists, don't like to do this.
greenaudit.org. Okay, have you got my email? Or c.busby@ulster.ac.uk.
Yeah, what we're going to do, sir, is we're going to give you our email, and if you could just write up in 2 paragraphs what you just said. Jaron, will you put Dr. Busby on hold and here in a moment and give him your email? And just because when the show ends, sir, I'm going to go write an article with Kurt and Emo. How fast can you send me just 2 paragraphs to be put in the story?
Well, I could do it in 5 minutes, I guess. Okay,
well, that's very gracious. Anything else you'd like to add, we'll put it into a story because you are highly respected, one of the chief advisors to the BBC as well. Just in closing, because you said something very powerful there, you're saying, and you've been proven completely right in your analysis of the last month and 2 days, you're saying, sir, that evidence points towards chain reaction, some type of atomic explosion in and around Fukushima, and that's what you're saying?
No, I'm saying that Chernobyl was a nuclear explosion. I'm saying that there's no evidence that there was a nuclear explosion at Fukushima, but my belief is that there was, okay? So we don't have evidence for that. We would have to have the xenon isotope ratios. But what I am saying is that all of this talk about hydrogen explosions and Chernobyl being a hydrogen explosion is not true for Chernobyl. Chernobyl was not a hydrogen explosion. It was a nuclear explosion.
Okay. I understand that, and what really puts the cherry on top of, or the coup de grace of this whole thing, is that they will never release the actual isotope readings, we've noticed, and for 3 weeks they wouldn't release anything for the 2 prefectures in and around Fukushima, which they now admit they didn't release because they didn't want to scare people, and that adds weight to what you're saying. If they don't want to release the exact isotope readings, that's because they don't want the fingerprint of atomic chain reaction.
It may be so, but my feeling is not that. My feeling is that they don't want people to know how much plutonium and uranium there is floating about, because that's the really dangerous stuff. All this iodine is the focus on iodine is a red herring in a way, and even on cesium-137, the really seriously dangerous isotopes are the uranium isotopes and the plutonium, because they are alpha emitters, and they come along as particles, particulates, so they float about the place like little hot coals, and then when you inhale them, they go inside you and produce massive doses to the local tissue. That's the problem.
Okay, we'll do this.
It's those particular alpha emitters that we need to know about, and we certainly need to know about them in the United States as well, because if there's a slight increase in iodine, it could well be that's associated also with the existence of these airborne particles, and it's the particles that are the problem. To say nothing of the tritium, we haven't heard about the isotope tritium, which will be produced in massive amounts as tritiated water, which sort of radioactive water. I would like to know very much what the tritium level is in the tap water in Tokyo.
Well, they have reported some tritium levels. I've seen that in the press. Now, expanding on this, and then we're going to let you go, just perhaps so we have a grasp of the history, a paragraph on the Russian incident, a paragraph on your meeting with the Russian scientist on Chernobyl, believing that was some type of atomic explosion, and then your statement on that. So we could have those 3 paragraphs from you, and anything else you'd like to add. We really appreciate your gracious time. And what is the best website for us to learn more, Dr. Busby?
We're putting all our stuff on the website of the Low Level Radiation Campaign, llrc.org. But in terms of the risk model, you need to go to the European Committee on Radiation Risk website, where we have now, because of the Fukushima accident, we have now released the 2010 report as a free download, so anybody can have. That cost £70. That was to buy that report, but now, because of the extraordinary developments in Fukushima, we feel that everybody should have access to that report. So it's a free download from the Euradcom, EURADCOM.org. You can get it from there, and this is the risk model that will tell you how many people are going to die after any sort of exposure.
Yeah, well, my dad separately took physics at UT, where they have a reactor when he was in college, and he said they taught then that they believed a meltdown could properly separate out, like you said, and then, I don't want to butcher what he said, but then some type of ion beam or almost electrical charge could go through it, and that could create the chain reaction. Am I butchering what he said?
I don't know. I didn't hear what he said, but the point is that if you have enough plutonium together in one place, the neutron flux gets high enough for it to achieve prompt criticality. So the question is whether or not the plutonium can separate from the uranium. Plutonium oxide can separate from the uranium oxide at these extremely high temperatures that there are. And I don't think enough is known to be able to say that that's impossible.
All right, amazing. We're going to put you on hold and give you that internal email. We've got make sure we've got your email, and we're waiting the next 20 minutes or so to get that key email so we can add that to an article we're going to do. Dr. Christopher Busby, thank you for joining us.
Okay.